All right, everyone, welcome. I see a few folks are still coming in, so we'll give them a couple more minutes. So please do submit your feedback for this session. Here's a QR code, and you get to enter into the daily prize drawing. All right, let's get started. So welcome, my name is Francis. I am a program manager on the Direct Ink team on the operating system groups of Microsoft. My colleague here is Xiao Tu, and he's a software engineering lead from the same team. We're super excited to be here to talk to you about Direct Ink. For those of you who are new to this concept, Direct Ink is the new Windows 10 inking platform for universal Windows applications. We have been working on this for more than a year, and we can't wait to share it with you. So a couple hours ago, there was a previous talk by my colleague Sriram, whose subject was about introduction to Direct Ink. This is the second part of the series, and we're going to build upon Sriram's talk to go more into the details. So by the way, did everyone watch yesterday's keynote demo? Did you guys see Staff Pad and all that exciting inking application? Well, so we created Direct Ink exactly to make this kind of scenarios possible. In this section, we're going to go more into the details of Direct Ink and how inking can make your app stand out. When we designed Direct Ink a year ago, we had a couple of objectives in mind. So one of those is we wanted to keep the platform simple and powerful right out of the box to enable you to add inking as easily as possible. And we also wanted to be flexible so that it fits a wide variety of scenarios. And finally, like a Microsoft tradition, we wanted to keep the platform extensible and customizable so that it can fit your unique needs. So for this first half of the talk, I'm going to cover the built-in functionalities and also talk about how to configure those functionalities to adapt to your app scenarios. I'm going to cover things like ink recognition through handwriting recognizer in order to add the level of smart into your applications. I'm going to talk about managing and editing ink through the built-in functionalities. And I'll get Ink to do some pretty neat things through event handling. The second part of the talk, Xiao is going to do a deep dive into the inner workings of Direct Ink, how to customize ink and input processing, and how to take advantage of the flexibilities and the customizability built into the platform so you can build top-tier applications like Staff Pad, Sketchable, and Office OneNote. All right, so let me start with a demo and see what inking can do in your app. So what I have here is a children's storybook application. Right now, it's pretty static, and it's pretty plain, just plain old text, like a lot of applications out there. Now look what I can simply do by adding ink. So now, adding ink allows me to personalize this app for the target audience, in which case my daughter Evelyn, it allows her to draw her figures into the application rather than just reading the static text. She can even put her name in here. Whoops, I made a mistake here. Fortunately, built-in erasing takes care of that easily. So ink is pretty smooth and fast right out of the box here. And this is all done by simply adding Direct Ink, simply by adding the ink canvas into the XAML. And ink canvas is one of those building blocks in this family of APIs that we call Direct Ink. It's a XAML control with rich built-in functionality. It interprets the input from the user and turns that into strokes and rendered on screen with low latency. It's very easy to use, and it's pretty good as it is. So why go any further than this, right? When I showed this app to my daughter, she came running to me and like, Daddy, I love it, but I want this to look like the marker that I used to draw our dining room wall. So of course I obliged, because better should do it in this app than draw in another, make another art in one of our rooms, right? So to do that is where, switch back to the PowerPoint. So in order to do something like that, this is where Ink Presenter comes in. And Ink Presenter is really the component that lets you further configure the ink. There's an instance of Ink Presenter with every ink canvas, and it's obtained as a property. So it's really the magic behind the ink canvas that powers all the things that, all the inking functionalities that you have seen so far. It lets you do things like changing the look and feel of ink, configure which input is used for inking, whether it's pen, mouse, or touch, or any combination of those input modalities, and even lets you configure how input is processed, so you can customize the interaction scenario. Through Ink Presenter, it offers you the flexibility to build applications ranging from the simplest signature app all the way to the more advanced applications like OneNote. Let me show you how to do that in Visual Studio. So coming back to our app here, and I'm just going to uncomment this piece of code. Run this. And it's compiling. Give it a couple of seconds, and there we go. So coming back to our app, now the black ballpoint pen ink is coming out like a marker. Notice the ink is looking much more interesting. We have different stroke thicknesses, depends on the angle of my pen here, and the same goes for this signature, or this signature box over here. And how I did this in the code is by creating what's called an ink drawing attribute. Now, ink drawing attribute is one of the classes inside Direct Ink, and it let me just change things like the shape of a pen, the size, the color, and even let me change the angle at which the brush is situated at. So that's exactly what I'm doing down here. I created a rotation matrix that turns the tip 70 degrees so that when the pen is going in one direction, it's thinner, and when it's going in another direction, it becomes thicker, giving you this calligraphy pen effect. And to set it, I simply set the pen tip transform to that matrix. And notice this statement here. So down here, I'm accessing the Ink Presenter property off of the ink canvas, and that's how I get to the Ink Presenter. And to set the drawing attribute, I call the update default drawing attribute function. So it's pretty cool, right? The pen is now pretty, and the handwriting is looking nice, but ink at this point is still staying as ink. What if we can make the story come alive for the user? So notice I click on the recognize name. Well, better have a, you have a better handwriting here. There we go. So simply by clicking on this recognition, now the story is truly my daughter's story. It remembers her name throughout the entire book, and it is truly personalized to her. This is done through handwriting recognition. Direct Ink provides handwriting recognition functionality out of the box, and so you can focus on writing cool applications rather than doing your own recognition. So the way to do that, let's come back to VS, is through what's called an ink recognizer container. So ink recognizer container is another one of those classes in Direct Ink. And it's where you start all the handwriting recognition functionality. So we create an instance of ink recognizer container. Then to recognize the ink, simply call recognize async. Now notice the first parameter I passed to the recognize async function. So here I got the ink presenter property. And then from the ink presenter, I access the stroke container property. Now, up until this point, you may be wondering, what happened to all that ink that the user had put on the screen? Well, by default, ink presenter stores that inside our own ink stroke container. And that stroke container is accessed through the stroke container property. All right, so that's pretty nice. What if my app is stripping another locale? A lot of the applications these days are created for multiple languages, multiple locales. And what if I want my handwriting recognition to be done in another language? The good news is Windows 10 ships with 35 handwriting recognition languages. And it's a simple matter to set the right recognizer. And that is done here. So we have our ink recognizer container. And the get recognizer function obtains all the recognizer installed on the system. And this line here, I've set it to look for the Chinese handwriting recognizer. So going through this loop, and once I find the correct recognizer, I then set it as the default. And it's that easy. So in my application so far, I've done recognitions through the click of a button. While it is sufficient, it's actually not that great, because wouldn't it be better if the user just writes down their name and automatically recognizes? Fortunately, to do that is pretty easy. And all I have to know is when the user has finished inking, and kick off the record once they've done it. So that's where the stroke collected event comes in. Ink Presenter provides events that notify the application at every stage of the inking, so you may choose what to do with those events. Stroke collected is one of them. It signifies when the user has finished inking and have lifted their pen. And another event I'm listening to here is a stroke started event. Between these two events, I can figure out when the user has finished their inking and is now ready to be recognized. So let's run it and see what we have. All right, so now I can write in Chinese. And if I just wait a little bit, there we go. My daughter's name Chinese is now being recognized in the app. All right, cool. So now the app recognizes my daughter's name. It lets her personalize it by drawing her little figure here. What else can we do to make it shine even more? Well, so the next page of the story calls for Evelyn living in a beautiful forest with lots of tall trees and fluffy bushes and so on. What if I want to make it easier for her to doodle and have that turn into actual trees? Now, what if we can just grow trees with the flick of a pen like this? Looks pretty fancy, right? So how do we do something like that? Well, the first piece is already there. Essentially, what I'm doing here is I change my stroke, this vertical stroke, into a collection of ink-drawn trees and brushes by listening to the stroke collected event. Now, in order to replace that stroke with something more complicated like the tree and the bushes, we got to load that set of strokes first. And this is where the ink stroke container class comes in. And you can what I'm doing here is I created a new instance of the ink stroke container, and then I have to load from file the set of strokes that makes up for the tree. Once I loaded it, I get all the strokes from that stroke container and then add it to the ink presenter's built-in stroke container. Now, the ink presenter's built-in stroke container is pretty powerful. Anytime you add or remove a stroke, anytime we clear the strokes or even change the drawing attribute, ink presenter knows that has taken place and takes care of the rendering update for us. So essentially, all I had to do is load the strokes, put them in the stroke container, and ink presenter takes care of the rest. And notice back in my application, the trees and bushes appeared at exactly where I drew my stroke. Now, how I did that is by looking at where the original stroke happened, and then I construct a scaling and transformation matrix to set it the right size and position, and then simply set the point transform to that matrix so that everything appears at the right place and the right size. So here we have it, from a plain old static text application to something that's truly personalizable through inking. So everything I've showed you so far here is done through the built-in functionality in Direct Ink. It's very powerful as it is, and can already enable wealth of experiences via configurations. With Ink Presenter, you can change the appearance through drawing attributes. You can manage ink stroke through the built-in erasing and stroke container functionality. And with stroke events, I showed you how to replace stroke with some other object, but you can do much more with that. Through the ink recognizer container, we take care of handwriting recognition with 35 languages. And with the ink stroke container, you can manage and edit ink. So for the second part of the talk, I'm going to turn it over to Xiao, who will do a deep dive into Ink Presenter and show you how to customize Ink Presenter to further adapt to your unique scenarios.
Thank you, Francis. So this is a different view of what Francis showed you, with just a little bit application code. You create an ink record container. The code talks to ink presenters, built-in ink stroke container, to be able to light up the built-in functionality and build very compelling scenarios. What I'm going to do is take you under the hood of Ink Presenter to understand deeply how we do rendering, how we do input processing, and how you can customize and build more powerful scenarios with the knowledge that you're going to learn. Under the hood, Ink Presenter built a high priority background thread we call ink thread. The ink thread takes pointer input to the ink thread directly, and the input goes to an independent input processor. This processor checks the configuration of Ink Presenter to make a decision whether that input is used for inking. If it's used for inking, the ink modeler is created to do the mathematical model of the inking. The mathematical model is built to consider different device types, whether it's mouse, touch, or pen. Also take into consideration of XY position and pressure The model is also tuned across a variety of Windows pen, touch, and mouse devices to ensure a beautiful, smooth experience. And also, the experience is consistent across the board. Then, the modular readout goes to a component called the wet ink renderer. The wet ink renderer works with the system compositor and the DirectX stack to do a very performant ink rendering. Internally, we use a concept called ink primitive. The ink primitive is rendered by the system compositor. Because of that, locally, we don't have to allocate DX resources or swap chain buffers to render the ink. That's the reason why internally OneNote loves DirectInk technology because it saves video memories. In the real world, when you draw with a physical pen, we all know that the ink stays wet for a while. Analogy is applied here while we draw with a digital pen, while the pen is touching the screen, we call it wet ink. As soon as the pen lifts, stroke builder builds the strokes, and the strokes dispatch to UI thread, and then we start to call the ink dry ink. A component called dry ink renderer is used to render the dry ink. Ink synchronizer is internally used to synchronize the removal of wet ink from the screen and the show of the dry ink so that they hit the display with the same display refresh. Then from an end user point of view, you won't notice any glitch or flickering effect. For the input that we decided not to do rendering, is internally dispatched to UI thread as unprocessed input. Because as we now know, ink presenter by default take care of the rendering. It has a built-in ink store container. Because of that, we were able to take the unprocessed input. For instance, when you push your eraser button, we don't do ink, and it's sent to UI thread as unprocessed input. We take those input, talk to ink stroke containers, we heat test the ink stroke, and that's how you see Francis' demo, we can do built-in erasing. So as we know, ink presenter now it has a very powerful built-in functionality. The reason why we can do all those built-in is because by default, we adopt a very simple model. The ink is an overlay above your application. Ink stays as one layer. And you may wonder, what if I want to go deeper and do something more interesting? So here I'm going to show you, I have a demo app. It uses DirectX to draw those random shapes in random location. Then the application, obviously, I can draw the ink. As you notice here, as soon as I lift the pen, the black ink is dry to a different color. We intentionally change the color so you can see the effect of wet and drying process. Then the code we can drop more shapes. As you can see here, there's a Z order. The shape is above those ink I just dropped. So now you can see there's some shape, there's ink above the shape, and then shape of the ink. And then you can add more ink, and then you can drop more shape, and then more ink. You may wonder why this matters. Why I want to do something like that? It's all about control. It's all about giving more control to applications. Imagine you want to build some very powerful application scenarios. You want to treat the digital ink just as another native content of your application. You want to treat ink the same as text, image, table. You may want to even go crazy to, when you relay out your text, you relay out your ink. You may want to anchor the ink with associated text or table or shape. And when that text is moved, you move your ink along with the text. These are the scenarios you want to consider activating a mode of ink presenter. Is called custom drawing mode. Another scenario that custom drawing mode may help is when you have a large canvas. Switching back to the demo app, what I have here is a large canvas that is about 1,000 pages. I have this button, allows me to actually scroll to 1,000 pages. I can keep adding ink there. And then when you have a lot of ink, you want to pan and add ink. You want this panning and zooming to be performant. Custom drawing helps scenarios like that. So what is custom drawing mode? It's a mode of ink presenter to allow you to dry the ink to your DirectX surface. In Windows 10, there are two types of surfaces supported. One is called surface image source. Another is called virtual surface image source. And we refer them as sys or vsys. Both of them provide a DirectX shared surface for application to draw into. The difference is virtual surface image source provides a greater than screen size shared surface for you to draw into. And this is the one I use in the demo app. This is the one that provides better performance panning and zooming. Then you may wonder, from the application code point of view, what the difference between the default mode and custom drawing mode. So here, refresh your memory of the default mode we talk about. Again, application doesn't have to write a lot of code, and you mostly talk to the built-in Inkstow container. But after you activate custom drawing mode, then you will write more code because you want to gain more control. Again, let's see the difference. The good news is all the building blocks we internally use, we expose as public APIs for you to use. You can create instance of dry ink renderer, instance of ink synchronizer, and obviously, Inkstow container instance. And also, obviously, you can continue to use the record container. So let's see the steps for application to do custom ink drawing. First, let's assume you're already familiar with sys or vsys. You already have an application able to draw your own content, such as the shape I show you in the demo app. But if you're not familiar with that, don't worry. There are samples in SDK to teach you how to do sys and vsys. Then, after that, the application creates instance of ink presenter. You get the instance of ink presenter from ink canvas, just like Francis showed you. And then you create instance of ink synchronizer, stow container, and the dry ink renderer is called ink D2D renderer. First, you hook up with stow collected event, and this will trigger your application code to do the custom drawing. First, you call begin dry, and the begin dry will return you a vector of ink strokes. You, in turn, add those ink strokes to your ink stroke container. Then you need to update the app join logic to call the ink DD renderer to draw the ink strokes you just collected. Finally, you call end dry to let the platform know you just rendered the dry ink. The platform will do the magic to remove the wet ink synchronously. Again, when we do that, there's no glitch, and from end user point of view, they won't notice the difference between wet and dry. Let's do a quick code walkthrough. Close the app. The same code, the code that is behind the app. So first, application need to call ink presenter, activate custom drawing, and this returns instance of ink synchronizer for application to use. So keep in mind when you do this, do it on application's initialization code. In this case, it's in the root page. Is right after the initialized component of the root page. If you do it too late, platform will throw exception, and it won't work. Second thing, the code need to co-create instance of ink D2D renderer. And notice here, this is a classic COM interface. After that, you need to create an instance of Inkstroke container. And this is what you use to manage the ink strokes, and you can do load async, save async, just like Francis showed you. As mentioned earlier, on stroke collected handler, you need to do a couple of things. The first thing is called the begin dry on the ink synchronizer instance. This will return a vector of ink strokes. And then the code pass that ink stroke to some internal code update scene. Later we'll see the two things this one will do. One is to add those strokes to the ink stroke container. And the second thing is to pass to the rendering component to do the rendering. After that, remember to call the end dry on ink synchronizer, so the platform knows to do the wet ink to dry ink synchronization. So let's go deeper to look at the update scene. The first thing it does is to add the strokes to the stroke container. And then here is actually all the magic behind the order effect. We have seen that you can have shape and ink with different reorder. And this is just a simplified view of typical application drawing code. And here you just go through a list of stuff, or all the shapes or object you want to draw. And all it does is just check the type. If it's ink, then I just draw it as ink. If it's something else, I just draw it as shape, text, image. And this way, it's totally within your control. You can compose the ink with the rest of the content, whatever you like. You can change the order. It's all within your control. And then finally, here's a code that shows how you update your rendering code to call into the ink D2D renderer draw function that takes 3 parameters. The first one is the D2D context that's created by your application. The second one is the vector of ink strokes. The last one is actually a flag for you to tell the platform whether you want to draw the ink as high contrast mode. And also keep in mind, in this mode, application owns rendering of the dry ink. By saying that, it's not only the lively collected ink. This also includes the ink strokes that's already in the ink stroke container. You may get those from a file. Your code may add strokes to that. You may remove. The code just needs to make sure it takes care of the update of all the other update of the dried ink strokes. Now let's run the application again. As we talk about now, in the custom drawing mode, application owns rendering of the dried ink. Because of that, the platform does not provide built-in erasing anymore. You may wonder how to get the erasing back, just like I just showed you. You may also wonder, for devices there's no active pen. If you want finger to be able to ink, and also with the mode switching, finger able to erase. How do you do that? And for people familiar with the OneNote or Win32 ink platform, there is another concept called selection. Selection is very powerful, is because with selection, you treat the ink just like text and other content. You can select it, you can move it around, you can drag and drop, you can copy paste. You may even want to make it larger or smaller. And how to build selection with direct ink. And similarly, how to enable a selection mode on devices without active pen, how you can use your finger to select. This takes us to the next topic. And I'm going to talk about advanced input processing. So let's first step backward to take a look at the invented model of ink presenter. As Francis showed you before, in the default dry mode, when we do some processing, we use the input to ink, we raise stroke collected event. We haven't shown you the code, but when we do built-in erasing, we also showed you, we also raise stroke event, erase event. So basically, when ink presenter does some default processing, we raise some event so that you know something happened. Francis also showed you when the input used for inking, you can register the stroke input event. This way, you can actually observe all the input that we use for rendering. And you can register this as a granularity of down, move, 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 up. If you want to go deeper, any of the input that the platform does not process is raised as unprocessed input. Later, I will show you how to use this to do erasing in custom dry mode. And someone may wonder, can I even process some input on the background thread and even take total control and before ink presenter does any processing? Answer is yes. It's because we love developers. We want to give you control. Later, I'll show you how to use that to build very powerful scenarios. Back to the custom drawing mode. In the custom drawing mode, by default, when you use your pen to ink, all the input comes as inking, and you get stroke input. When someone pushes the barrel button, there's no built-in selection for barrel button. As a result of that, we actually just ignore the barrel button. We continue to process as inking, and you can observe those as stroke input. And as I mentioned earlier, when you push the eraser button, there's no built-in erasing support, and you can get those as unprocessed input. You may wonder, how do I have better control of the input processing? There are two ways. One way is for any of the input, you can change the input processing configuration mode to none, and those input will hit the unprocessed input handler on the UI thread. That way, it's totally within your control. For barrel button pushed event, you can change the right drag action to leave unprocessed. That way, it won't ink, and you can use that one to support selection. Let's come back to the code and see how to support erasing and selection in the custom drawing mode. It's very simple, and the first thing you need to do is to add event handler to the unprocessed input. And all the event args we give you, those are typical pointer event args that you probably, if you want to read talk, you are familiar with pointer input. And after that, you just need in your handler to use the input on pen up, in this case in the demo app, and use that input. This is actually, so this is for erasing. So it's like every pointer move, you remember the previous point and the current point. You have a line, and then you use select with line method on install container to do the heat testing. The method will return you a rectangle, and that rectangle can be used in your rendering code for the dirty region update so that it's performant. For touch, I showed you the erasing mode. How to achieve that is when user push the eraser mode button, the code just need to change the input processing mode to none. And after that, the same code I just showed you, to process unprocessed input to do heat testing for erasing, just works for touch. For barrel button-based selection, like I showed you earlier, all you need to do is change the right drag action to leave unprocessed. Then the same handler of unprocessed down move up will be hit. And then in your handler, in the demo app, we don't do a live selection. The selection only happens on pen up. The code just take all the array of input and pass to this method on install container called select with polyline. Again, this method returns you a rectangle to use as a dirty rect for your D2D rendering code. This way, you get barrel button-based pen selection. Similarly, for touch mode, after the user change the button to selection mode, then the code change the input processing mode to none. Again, The input will hit the unprocessed handler, and the same heat testing code just showed you just work. Let's run the app again. You select. Try again. Now, after selected, you may wonder, how do I drag and drop this in another location? Oh, doesn't work. It ink. Why? This is because this rectangle was drawn by the application's D2D code. OS doesn't understand the rectangle. As pen is done, we just use to ink. So how to solve this problem? That takes us to the next topic. The next topic is about how to go deeper, run some lightweight code on the background thread to do lightweight heat testing, and dynamically change the input processing mode to none so that you can dynamically change the mode so that if the pen is outside the selected rectangle, it's inking. If it's within that rectangle, you transform the selected ink strokes. It's very simple. On pointer pressing handler, you take the input and you do some heat testing. When you find the input land within the rectangle, you call the same API to change the mode to none. And after that, the same unprocessed input handler will be called. And then you can map the movement to the point transform API, the same API actually Francis showed you earlier. Let's take a look at the code. So first thing is, in order to register independent input, you need to create an instance called core independent input source, and then use that one to register the pointer input. The application already registers all the pointer input for other purpose, but for this one, you actually only need to register for this one. It's called pointer pressing. The reason why it's called pressing, not pressed, is because you are going to be the first one in the pipeline. And it's pressing means you can take total control. You can change applications, change the platform's behavior dynamically. And then here's the code. It's very simple, just a couple lines of code. What it does is just on pointer pressing, it does a very quick heat testing to check whether the input is within that selected rectangle. If it is, then you change the input processing mode to none. Let's run the code. So keep in mind, when you do that, you start to do multi-threaded programming and just follow the typical multi-threaded programming practice and use a log. On the other hand, you're running code on the inking thread. So making sure it's very lightweight, otherwise you may slow down the wet ink rendering. And let's see, again, select. I can continue to ink outside, but if it's within, I'm moving this one around. It's very simple code, very powerful scenario. So switch back to presentation. Now you may wonder, how can the application do more? With all the knowledge of custom drawing, to a VSys, have a large canvas, custom processing of input, support erasing. There's another thing you can do when the application is a custom drawing mode, is to enable very powerful surface hub type of multi-pointer, multi-pen, multi-finger inking scenario. All you need to do is to change one predefined configuration. And that's it. That gives you what I'm showing here in the video. This is the Surface Hub, 2 pens inking at the same time, very performantly. One pen inking, another pen erasing. Erasing on UI thread does not slow down the inking. 3 pen inking at the same time. And now they go crazy with 20 fingers inking at the same time. Thank you. Now back to Francis.
Thank you, Xiao. All right, so what did we learn today? First of all, Direct Ink makes it super easy for you to add ink into your application, and so that you can actually focus on creating great user experiences rather than worry about drawing the ink itself. We offer a great set of functionality right out of the box, and there are plenty of ways for you to configure it to suit your app scenario. And for the advanced scenarios, Direct Ink lets you customize how ink dries and then renders with other content. And you can even customize the input processing so that you can create some very unique interaction scenarios. All right, so that's our presentation. I do have a few things I'd like you guys to do. First of all, there are several related sessions. Like I mentioned a couple hours ago, my colleague Sriram have held the Introduction to Direct Ink talk. It's got a lot of great background information on the science of inking, so highly recommend you to go watch it. There was also a session on building apps for Surface Hub, like the multi-pen scenario you just saw, but it's not limited to that, it's much more. It's also a great session if you're into building Surface Hub applications for the enterprise and meeting room scenarios. And finally, my colleague Reed have had a input talk yesterday, and this gives you a great background and intro into how to do input handling in Windows 10. We do have a hands-on lab for you to go try Direct Ink live and then also win prizes. And Xiao and I will be sticking around here for a few minutes as well as in the Windows Insider Lounge to answer any questions you might have. And my last ask is go build Windows applications with ink. We'd love to see what kind of creative scenarios you guys come up with, and send us feedback at directink@microsoft.com, and we'd love to hear back from you. One last thing, please do evaluate this session and have a chance to win prizes.
And we can take a couple of questions.
Yeah, I have 2 questions. Great presentation. One is, how does the WPF inking relate to what you've been talking about? Because it has some similar capabilities, but I'm wondering if any of the Windows 10 WPF inking will be changing to use some of this. And 2, how do you do custom rendering in the strokes? So, for example, you wanted to have a certain type of effect in a stroke rendered with ink strokes.
Great question. The first question was about how WPF inking related to this. The quick answer is it's very similar. One of the reasons was I was actually one of the developers on the WPF ink canvas. So the Direct Ink API design was greatly influenced by the WPF APIs. The major differences are, right now, I think the WPF ink canvas actually has richer functionalities. On the other hand, the universal Windows application ink presenter provide way more beautiful ink rendering, lower latency, and smoothing, and there's a lot of good stuff not there in the WPF.
And the custom rendering question?
So custom rendering is for Windows 10 right now. The ink presenter does not support overriding, have your own custom rendering, but this was something we considered in the architectural design. That will be a future consideration how you can plug in your own custom rendering. That's a good question.
Thank you so much.
Also, one more thing I would like to add, and Xiao, please correct me if I'm wrong, but WPF inking was designed at a time when touch was still not prevalent. So in order to do the type of touch and inking, simultaneous touch and inking scenario that we have today, WPF isn't very well suited for that. But direct ink is designed from the ground up to do that kind of scenario.
Follow-on question to that. If I do have a WPF application, could I use this direct ink in that application as on Windows 10?
My suggestion for you is actually move the application to direct ink.
Thank you.
And if you feel free to email direct ink at Microsoft to follow up on the custom rendering. Love to understand your scenario and how we can better support your scenario in the future.
Okay, first of all, are we gonna, is the code gonna be available for these samples that you've presented here?
For my presentation, it's those sample code will be available at RTM timeframe.
Oh, okay. And then, is there a way to get the stroke geometry in some way that you could then, you know, I mean, in previous versions in WinRT Inc., I've been able to get Bezier curve information, for example. Is there a way to get the more beautiful, you know, processed shape of the strokes?
Good question. So the same API that work in Windows 8, 8.1, we took all of them to the Universal Windows platform. So those will continue to work. For the new ink model I talk about, the modeled Bezier, right now there's no API to retrieve those Bezier curves. That's the reason why we provide the dry ink renderer for application to draw the ink with the same experience. But I would love to understand your scenario, why you need to get those Bezier curves and see how we can better support your scenario in the future.
Okay, and then finally, is there a way to simulate input? I never figured out how to do that in previous versions. If I have, you know, points, pressures, maybe angle for a pen, can I somehow then, you know, pass that to this so that to simulate that input?
Good question. For input simulation, depends on your needs. In Windows 10, we have APIs already. You can play with that. Those are APIs called in the stroke builder. The APIs for you to create ink point and create strokes. And this way you can actually manufacture ink strokes, add to ink presenter, and in the default drawing mode, we're actually going to treat them as real input and render them in a consistent way. But if your need is about fake real input, so that actually I'll probably ask you a question. What is your scenario? Do you want does what I described good enough for your scenario, or you want to do something else?
Well, so what I would like to be able to do is, I don't see myself being able to implement anything as good as this on another platform. But if I have another platform, I'd like to be able to do something, a cruder version of it, and then have that data get passed over, but then you know, presented using this along with native, you know, code that's input on Windows 10.
I see. So as I mentioned earlier, if your need is about rejoin the dried ink, we do provide support for that. Say you have your own data format, you want to load from your file, you can create ink stroke and pass to the platform. We're going to do it on your behalf.
Okay, all right. I may follow up with you, but thank you very much. It's a great presentation.
Thank you.
All right, thank you, folks.
Okay,
That's
thank
it.
you all.